The next decade will be India's techade. These are the words of Indian Prime Minister Narendra Modi. The tweet was made on the occasion of the laying of the foundation stone for three new semiconductor factories at various locations in India. In the last two episodes, we have been exploring the semiconductor industry. The first part was on understanding the overall industry, the second part was on the US CHIPS Act, and in this third part, we will understand what policies the Indian government has implemented in the last couple of years to pave the way into this sunrise sector. But before proceeding ahead, here's a small request to everyone. If you are liking what I am doing, then please support the channel by buying me a coffee or a lunch, whatever you want. At the end of the description of this video, you will find a link where you can contribute any amount of your choice. This money will help in keeping this show up and running. And if not that, then the least you can do and the least I can ask for is to press the like button, share this video and subscribe to the channel. Your one action can trigger the algorithm and will help in making this video reachable to everyone. Thank you. Now back to the episode. Indian government implemented PLI or Product Linked Incentive Scheme for semiconductors. But nowadays it is not called as PLI. According to this scheme, the government supports the project financially by giving them the incentive of 50% of the entire project cost. Over and above that, states have to announce some policies including financial support of an additional 10 to 25% of the project cost and even subsidized land and discounted electricity tariffs. Unlike other PLI schemes where the government gives incentives if the company achieves a production target, the incentive structure for this sector is a bit different. Here, the government almost invests in the project, saying indirectly that the stakes involved in this sector are higher. Four companies have received approval under this scheme. First, Micron. They are setting up a plant in Sanand, Gujarat, with an investment of more than 20,000 crore rupees. It is an assembly, testing and packaging unit, also called as ATMP unit. It aims at 17.5 million chips per day and can be operational by 2024. Second is Tata Electronics. This is in partnership with Powerchip Semiconductor Manufacturing Corporation or PSMC of Taiwan. They are setting up a plant in Dholera, Gujarat. Dholera is nowadays termed as Semicon City of India. Total investment will be 91,000 crore rupees. Focus will be on 12-inch wafer fab and 28 nanometer technology chips with a capacity of 50,000 wafer starts per month or WSPM. What are wafers, chips, 12-inch, 28 nanometer, ATMP, WSPM? Yes, I know these are a lot of jargons. I will clarify them in a bit. Third is another Tata company, but this time it is solo. Tata Semiconductor Assembly and Test Private Limited will invest 27,000 crore rupees in Morigaon, Assam. Again, this is an ATMP unit. Lastly, it is CG Power along with Japanese company Renesas Electronics Corporation and Thai company Stars Microelectronics. They are also coming in Sanand in Gujarat with an investment of 7600 crore rupees. They have the capacity of 15 million chips per day and this will also be an ATMP unit. So in all, the total investment will be rupees 148,000 crore, slightly less than 1.5 trillion rupees. Now, let us understand this scheme in detail. The government has proposed incentives of 76,000 crore rupees, which as per current rates is equal to $9 billion, around what Germany has set aside, which is $10 billion. There are four schemes under India's semiconductor mission. First is called Modified Scheme for Setting Up of Semiconductor Fabs. This is for actual manufacturing. In the first part, I have mentioned what fabs are. They are actual place where chips are manufactured. We will come to the details of this scheme in a while. Second is called Modified Scheme for Setting Up of Display Fabs. This scheme is for display fabrication facility. Display fab is nothing but manufacturing of the displays that are used on screen for various devices. This is not directly linked to semiconductors as such, but India is the largest importer of liquid crystal displays or LCD that we use everywhere these days. Therefore, this scheme might help us in reducing import bill if we become reasonably self-sufficient. Third is Modified Scheme for Setting Up of Compound Semiconductors, or silicon photonics or sensor fabs or discrete semiconductors fab and semiconductor assembly, testing, marking and packaging, which is ATMP, or outsourced semiconductor assembly and test, that is OSAT facilities. Let us understand these terms in brief. First was compound semiconductors. Compound semiconductors are semiconductors that are made from two or more elements. Silicon is made from a single element and therefore it is not a compound semiconductor. They are used in LEDs, infrared detectors, optical devices, aerospace and defense systems, etc. Second, silicon photonics. There are various photonic systems which use silicon as an optical medium. That is called silicon photonics. Now, photonics is a technology which are used in barcode scanner, laser surgery, quantum computing, etc. In short, an application where there is a use of light or laser or any optical device. Third, sensors fab. That means a fab that manufactures sensors. Fourth, discrete semiconductors. These are single devices with a single function, such as transistors or diodes. They are used in power supplies, audio amplifiers, radio frequency devices, motor control systems, and other areas. Fifth was semiconductor assembly, testing, marking, and packaging, which is called ATMP. We just heard about it a while ago. It is the last process in the whole semiconductor industry. So here we are encouraging companies not just to set up manufacturing plants, but also ATMP processes. Sixth was outsourced semiconductor assembly and test, which is OSAT. OSAT suppliers are basically third-party providers of semiconductor assembly, packaging, and testing services for semiconductor integrated circuits. They specialize in these activities only. I feel that the process is similar to what we discussed in ATMP. I guess you can use them interchangeably. If I am missing something, then please put that in comment section. ASE Group, Amcor, JECT, SPIL are key OSAT players. Also, many companies coming into India are into OSAT or ATMP facilities only, as we discussed earlier. So yes, this was the explanation for the third scheme. We just covered the name of the scheme. Now let us move to the fourth one. The name is Design Linked Incentive Scheme. This is the policy for companies into designing the chip. Remember in the last episode I told you that US is best at designing and Taiwan is at manufacturing. That is the designing aspect, and we have a policy which will incentivize designing in India. But it is slightly different as we cannot jump too many things at the beginning of our journey in this new industry. So basically, these are the four schemes. The first one was for pure fabs, which will manufacture chips. Second is for display manufacturing. Third is for different types of semiconductors and different processes. And fourth is for designing. Now, let us understand the financial angle. Let's start with the first scheme, which was for semiconductor fab manufacturing. This scheme is for many types of semiconductors like logic chips, memory chips, etc. We discussed in the first part about what these types of chips are. According to this scheme, the wafer size should be 300 millimeters. Now, what is wafer? So yes, we have now transcended from chip to a wafer. Basically, if you have a semiconductor material and you take a thin slice of that material, that is called a wafer. They do not have any inherent functionality, but it is a platform on which chips are built. They are available from 25.4 millimeters to 450 millimeters. Currently, 300 millimeter is the common size. Semiconductor plants are known by the diameter of wafers they produce. A large wafer diameter enables producing more semiconductor devices from a single wafer. So basically, it's like a roti or a pizza. If the diameter is increased, you get more pieces out of it. Then comes the installed capacity restriction, which is of 40,000 wafer starts per month or WSPM. That's how the capacity is measured in the case of any fab. Usually the capacity depends on many things. For example, Samsung has built world's largest fab in Korea, whose capacity is 4.5 lakh WSPM or 450k WSPM. There are fabs with lower capacity too. In 2023, Pragmatic Semiconductor's plant in UK got operational, and that had the capacity of 15,000 WSPM only. Now, let us understand the entire chip and wafer issue in depth. One modern car needs 1,000 to 3,000 chips. Let us assume average of 1500 chips. And from one wafer, you can create around 300 to 400 chips. That means 40,000 wafers, which is basically the restriction Indian government has put. From that, we can create 40,000 into 300, which is a conservative estimate, that is equal to 1 crore 20 lakh or 12 million chips. And remember, this is every month because the short form is wafer starts per month, WSPM. Therefore, every month, Indian made chips can be used in manufacturing of, on average, 8,000 cars, assuming 1500 chips per car. If we assume higher chip requirement of 3000 chips per car, then we can use them in 4000 cars. This is monthly for one fab, and that too assuming it is running at a full capacity. So we concluded with that one plant, we will be able to use those chips in 4,000 cars per month. In financial year 2023, we produced more than 3.8 lakh cars a month on average. So yes, one plant is not going to help us in any way. We need more plants, and therefore these are baby steps. And mostly, many companies start with lower capacities, but as they succeed, they increase their capacities too. So to start with, 40,000 WSPM as a minimum requirement looks valid. Next criteria is minimum investment requirement, which is fixed at 20,000 crore rupees or 20 billion rupees, which is more than $200 million. In the previous episode, we saw that it takes around 3 to 40 billion dollars to build one plant, which is basically a total cost of ownership of that plant. So from that angle, this minimum investment requirement seems very low. Then there is another threshold of minimum revenue. It means that the company should at least have 7,500 crore rupees or 75 billion rupees of revenue in any of the 3 years before it submits its application. To get an idea, let us see the types of companies which are around 7,500 crore rupees sales. CG Power, who recently got an approval for a semicon scheme, registered close to 7,000 crore rupees in FY23. Similar for Dixon Technology. ABB's sales for 2023 were more than 10,000 crore rupees. Sales of Hitachi Energy, on the other hand, were slightly above 4,000 crore rupees in FY23. Now, the most important part, what is the incentive? What the government is going to offer? The fiscal support will be 50% of the project cost. That means if the project's cost is 40,000 crore rupees, then the government will pay 20,000 crore rupees. At the same time, the government may also extend benefits of some other government schemes too. There is one condition, and that is 2.5% of total cost should go to R&D. In this way, we will also improve our R&D facilities, and that will benefit the entire ecosystem, right from education to final product output. Now, we will skip the second scheme as it is not directly linked to semiconductor chips. Let us move on to third scheme. There are two parts in it. First is for different types of semiconductors like compound semiconductors, sensors, etc., which we have already discussed. And the second is for assembly testing, marking and packaging, which is ATMP, or outsourced semiconductor assembly and test, OSAT facilities. Now under the first part, these are the conditions. The wafer size has to be 150 or 200 millimeter or more. In the earlier scheme, it was 300 millimeter. In the case of wafer size, higher size is more advanced. So that means here we are allowing some older generation wafers too. Then the capacity has to be 500 or more WSPM. Earlier it was 40,000 WSPM. So if we compare with the previous scheme, here we are talking of very smaller size and processing. Also, in this scheme, we want a company who already has a similar plant somewhere to come and set up a new factory in India, or at least have the license for this kind of technology. Then, minimum project cost should be 100 crore rupees or 1 billion rupees. In the earlier scheme, it was 20,000 crore rupees. If all these conditions are satisfied, then the government will pay 50% of total capex or capital expenditure. Now let us come to the second part, which is assembly and testing or ATMP. The conditions are pretty much similar. Minimum project size must be 50 crore rupees. That is even lesser than the first part of the scheme. And the government incentive is also same. That is 50% of capex. In both the cases, the company must allocate 2.5% of capex to R&D. This was the third scheme. Now let us go to the last scheme of design linked incentive scheme. Here our focus is on the most value added thing, and that is designing. But it is not that easy. The scheme is for different processes. First is for development and second is for deployment. Development related part is called product design linked incentive. Here the government will give 50% of the expenditure as incentive up to 15 crore rupees. Deployment related part is called deployment linked incentive. Here the government will reimburse the expenditure in different manner. It will give 4% to 6% incentive of total sales over a period of 5 years. And there is a ceiling of 30 crore rupees. This is actually catering to startups and smaller businesses, as the government wants them to start designing for smaller parts in the entire value chain. One of the objectives is nurturing 100 domestic companies of semiconductor design for ICs, chipsets, etc., and facilitating the growth of not less than 20 such companies to achieve the turnover of more than 1500 crore rupees in the next 5 years. The dreams are very big right now because we want to nurture 100 domestic companies. And the reality is that only 7 companies have been approved until January 2024 and 2 have been approved in February. So the success rate of this scheme is still low. One of the main reasons is that the government restricts such companies to get any foreign capital. So this was about the last scheme. So all in all, it is a good starting point for India. There's little done if you see the entire semiconductor ecosystem, but nevertheless, we have started this journey. It is important because we have started it couple of times earlier also, and there hasn't been much progress. Largely, government and bureaucracy was a big hurdle, but at the same time, China was more attractive. And it is not that the Modi government has not tried it earlier. BJP government too has tried before COVID, but there wasn't much success. A lot of this happened after COVID and because companies wanted to diversify out of China. And that's where India grabbed this opportunity with this kind of scheme. Many countries want companies to come and manufacture, and probably this time many will succeed also. The main thing which I feel is what kind of work will be outsourced to these countries. In the case of India, out of 4, 3 are ATMP facilities, which means low value added part of entire supply chain. Tata and PSMC's Dholera plant will be the only fab manufacturing plant in India. But I've told you in the previous episode that countries like India, which does not have any prior experience in this industry, should focus on ATMP type of work and then slowly and steadily try to get creamier work like manufacturing and designing. Right now, most of the manufacturing is going to US, Japan, Korea, etc., where they already have some higher level of sophistication and experience in this industry. In the case of emerging markets, India, Malaysia, and Vietnam are the top choices for any chip manufacturer or even ATMP facilities right now. There are many things about semiconductor policy of India that I have not covered in this episode. This was just a basic introduction of India's semiconductor mission and its policies. Critique, opportunity, and what other countries are doing, everything is yet pending. So for now, I will not release any episode on semiconductors because I think I should take a break and maybe I should give you some break too. Probably in the next couple of months, I will gather more information about this industry and come back with more episodes on it. But till then, tell me what you would like to know more about this industry, about India's progress, about progress in other countries, etc. That's all, folks. Do support this channel. If you have learned something new today, then like it. If you think that this information will be useful for someone else, then do share this video with others. And yes, don't forget to subscribe to the channel. Thank you. Goodbye.